Hi friends, in this video I am going to explain about the relation between the time response analysis and frequency response analysis. Okay, so actually in case of time response analysis, so we know about the first order transfer function and the second order system transfer function. Okay, so first order means what? Whenever we are going to get the transfer function, for example, the relation between the output by input T of s is equal to C of s by R of s, that is equal to 1 divided by Ts or 1 divided by 1 plus Ts. So this transfer function is the first order response or first order system transfer function. But in case of second order system, the transfer function is always T of s is equal to C of s by R of s, that is equal to omega n square divided by s square plus 2 zeta omega ns plus omega n square. So this is the standard transfer function of a second order system. Clear? So now in this concept we are going to discuss about the relation between the time response analysis and frequency response analysis. So how we are going to get the frequency response analysis from the time response equation or the time response analysis transfer function. Clear? So already we know the second order system standard equation, that is what? So T of s is equal to C of s by R of s, that is equal to omega n square divided by s square plus 2 zeta omega ns plus omega n square. So this is the time domain or time response analysis second order transfer function. Now how to get the frequency response from this time response equation means just to do or simply instead of s just to substitute the j omega. It means instead of s or in place of s substitute the j omega, then simplify the total equation, you will get the frequency response analysis. Okay, so simple what I am doing here, so I am taking the second order or the standard form of second order system transfer function. So T of s is equal to C of s by R of s, that is equal to omega n square divided by s square plus 2 zeta omega ns plus omega n square. So here just to put s is equal to j omega. So we are talking about the frequency response analysis means definitely the frequency term here we need to include. That's why just see here, whenever we are going to put s is equal to j omega, so omega is what? Omega is equal to 2 pi f. F is frequency, yes or no? Or we can also call it as, so omega is also a angular frequency. Clear? So here after putting s is equal to j omega, just to substitute s is equal to j omega in the standard equation or the standard form of a second order system transfer function. So after that, so by putting s is equal to j omega in the equation, so C of s by R of s, so instead of s we are substituting j omega, that is equal to T of s, that is equal to what? Instead of s again we are substituting j omega. So T of j omega is equal to omega n square divided by s square means j omega whole square plus 2 zeta omega ns. So here instead of s again we are substituting j omega plus omega n square. So after that, after substituting j omega, s is equal to j omega, then from this equation just observe I am just reducing the total transfer function. So here divide and divide the divide with omega n square in the numerator and the denominator. Clear? So by in numerator and denominator simply we are dividing with the term omega n square. So after dividing with the omega n square in the numerator and denominator, so just see here, so T of j omega is equal to omega n square by omega n square 1. So that's why 1 divided by here j omega square, next 2 zeta omega n into j omega plus omega n square. Here omega n square divided by omega n square means 1. So that's why here 1 minus, again just see here, j omega square divided by omega n square. It means, so j means what? J square. Here j omega square means what? J square omega square divided by omega n square. Here j square means what? Minus 1. So that's why minus 1 into numerator omega n square divided by denominator omega n square. That's why, so minus of omega by omega n whole square plus here again j into 2 zeta omega n, here omega n numerator term and divided by omega n square means 1 omega n cancel. So remaining term is what? J 2 zeta omega divided by omega n. Clear? So after solving this total term, we will get this total equation. Clear? So after that, what I am doing here, omega by omega n square, and here also say omega by omega n square. Clear? So this total term is related to frequency only now. So that's why what I am doing here, for again for more simplification purpose, just I am substituting omega by omega n is equal to u. Clear? So just to put omega by omega n is equal to u. So after that, here just see here. So T of j omega is equal to 1 divided by 1 minus omega square plus 2 zeta omega into omega by omega n is u. That's why into u. Clear? So after that, this is the total transfer function in sinusoidal. Clear? Because whenever we are going to study about the frequency response analysis of any system, input is always sinusoidal. Yes or no? Already I discussed in the last video. Clear? So here, this is the total transfer function of a system. Now what I am doing, whenever we are going to get the complete frequency response, so always we need to get the magnitude of this equation and also we need to find the phase angle of this equation. So after getting the magnitude and the phase angle, then get the final response. Clear? So here, so after getting this total equation, calculate the magnitude m, capital M, and phase angle phi. Then just see here how to calculate the magnitude. Already we know already I discussed in the last video how to calculate the magnitude and how to calculate the phase angle. Clear? So here mod of k, simply magnitude of the total T of j omega, mod T of j omega is equal to capital M is equal to, so how to calculate the magnitude means root of r square plus x square. We are going to follow the same rule for everything. Clear? So here root of 1 square, here 1 square and here root means 1 by 2. So finally we will get what? Only single 1. Clear? And divided by this total term 1 minus omega square is a real part and j into 2 zeta u is the imaginary part. That's why, so in the denominator under root real square plus omega imaginary square. Clear? So here real is what? 1 minus u square whole square plus 2 zeta u whole square. Clear? So this is the magnitude of this function. Clear? And after that, after calculating the magnitude and calculate the phase angle phi. Clear? So how to calculate the phase angle? So angle T of j omega is equal to phi is equal to tan inverse of imaginary by real. Already I told you in the last video. Clear? So tan inverse of imaginary by real. So that is equal to tan inverse of what is imaginary term here? Imaginary term is always 2 zeta u because the term, this total term is multiplied with the j. Clear? So here tan inverse of 2 zeta u divided by real part 1 minus u square. Clear? So this is the angle, this is the phase angle and this is the magnitude of this total equation. Now how to get the final response? So output to C of t is equal to, so C of t is equal to magnitude at an angle. Clear? Already you know the equation of a output, that is what? So C of t is equal to some b into sine omega t minus phi. So same in, just we are substituting, instead of b we are substituting the value of m here, magnitude m here, and instead of phi just we are substituting the phi value, total tan inverse of 2 zeta u divided by 1 minus u square. Clear? So this is the actual output of a system. Clear? Now after completion of this, so what we are going to do, we need to draw the frequency response curves. So how to draw the frequency response curves means, so the term u, when we are going to vary the value of u in this equation, you will get different phase angles and different magnitudes. For example, when u is equal to 0, what is the magnitude, what is the phase angle? When u is equal to some infinity value, then what is the magnitude and what is the phase angle? So with the help of, or simply by varying the value of u, you will get different magnitudes and different phase angles. So with the help of all these different magnitudes and different phase angles, you can draw the frequency response curves. Okay, so this is a very important concept in the frequency response analysis. Thank you so much. And in the next class, I am going to draw the frequency response curves with the help of this equation. Clear? Just to follow this one. Thank you so much.